Almost done, man.
Hey guys, how's it going? Invoking native code from Java was always a bit hot topic nobody wants to touch because you just can't do it wrong. Either you're going with JNI, so you have a lot of C to write, and possibly you don't know the C language at all, and it feels not really natural to the Java platform because you want to do things in Java, right? You don't want to write a C DLL and ship that, and write a shared library for Linux and ship that, and so on and so on. You just want to do Java. On the other hand, there are external projects like JNA, which is really great, and I love to contribute some API functions to JNA. But, well, it makes things a little bit easier for you as a user, but for the platform, it's still a lot of work to go all down these levels through the JNA platform until you reach actually your native DLL. So, what could you do? What you actually want to have is native support inside of the Java runtime itself, which means you just write Java code to load native binary code, and the Java runtime itself will deal with all the technique under the hood. So you wouldn't have to deal with third-party libraries like JNA, which you have to ship and which don't exist for some platforms you might want to supply. So if there would be something inside of the Java runtime itself, then it would exist on all platforms, on all operating systems, and you could use it just because it's there. Wouldn't that be great? Wouldn't that be the holy grail of invoking binary code from Java? And here it is. Welcome, entering the stage, the foreign linker API in JDK16. One great aspect when it comes to the foreign linker API is that it works fine in conjunction with the foreign memory access API, which is new to Java 14, I think, and it's still in incubator 2. But both APIs really work great together. So what's the foreign memory access API? You can imagine it like that. You have real memory managed by the operating system, and you work with memory addresses there with pointers in C language, okay? So you can directly access and pass around that pointers. You don't have to move data from the operating system memory into the Java heap or the other way. You just pass around the pointer. So you can use your original data. It stays in the original memory location. It is not moving. You just give the pointers that you got back from your operating system back into your operating system. So it is way faster than actually modifying or migrating your data at every call. This is really great, and it will improve performance by far. And it is easier to use than the Java NIO memory access that we know from years back. One thing you cannot get rid of, and you have to take care of that, is that when you invoke native code, that native code will be different on each platform still. Java will not make this go away. So let me do an example. When you want to show a message box on screen, on Windows you call a Windows 32 API function for that. So if you go on the Mac, there will be a different API you have to call with different parameters. Or if you go on a Linux desktop, you have a third API that you have to call, which has a different name and which is using different parameters. So this difference will not go away. The reverse is the case. Actually, the foreign linker API allows you to deal with that differences in the Java language. So if you want to write a custom API for showing a message box on screen that works on all platforms, the foreign linker API is just a tool that enables you to call native APIs. But you have to do the separation into the platforms inside of your Java program. So still, you have to deal with platform differences, but it's way easier and it works on all platforms and it's really fast. Okay, enough with the talking. Let's do some code hacking. Let's do exactly that. Let's call the Windows API to show a native message box on screen triggered from Java without any C language involved. Here we go. What we see here is the complete Java code, which means the complete code because there's only Java and there is nothing beside that. No third-party libraries, no C language, just this piece of code. And I will show you how to use it. It's really, really pretty simple. The first thing we have to do, we need to write a module info Java because we require an incubation feature, which is in the module JDK incubator foreign. This is needed because it's still in incubation. So later we will have this in the normal JRE. So the module name will definitively change. So now that the compiler knows which module we want to load, we can use the APIs found in there, which is the foreign linker API and the foreign memory access API. And it's pretty straightforward to use it. Let's start our program with the main method, and the main method will get the arguments from the command line, and the first argument at the command line shall be the text that is in the message box, and the second argument shall be the caption of the message box. We just pass them in our method message box. Here you can see it, message box will get the text and the caption. So inside the method message box is where the magic is going on. So let's first load the DLL. This is what library lookup of library does. This is the name of the DLL that I'm loading, and it's part of the Windows API. The user32.dll exists on every Windows PC, so I can even get rid of the .dll extension because that's the default extension on Windows for shared libraries. What I get back is a wrapper around that DLL, so this is a bit of Java code that lets me deal with DLLs. With that wrapper, I do lookup message box W. So this is like looking into the DLL. Where is the actual code that will get executed, the binary code of the function message box W. By the way, the W is a Windows thing. It indicates that I want to use a Unicode version of that method. So now we can call that native function. But for that, we need a little trick because the Java runtime cannot know the sequence of parameters or the types of parameters. This is just not found in native code. So somebody has to tell Java what a sequence is, and that somebody is you. So what do we do? In the first step, we use method type. And method type will define a new Java method type. So this is the Java interface that you want the Java runtime to assume that would exist. You invent that on the fly. And we want to have an integer, sorry, you can read it, an integer. Then you want to have a memory address. A memory address, simply spoken, is a heap pointer on the native operating system. So we have 3 pointers here, and we have an integer here. Why is that? Because in C, this is the same in C, you would have written int, pointer, 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 int. So where did that get from? Well, actually, this is inside of the Windows API description that you can find on the web. It says message box wants an integer, 3 pointers and an integer. And certainly you have to know what the pointers point to, right? So you have a function description in C language, and you have a function description in Java language. So now the runtime knows how to map the left side on the right side. And next we come to the real magic. There is a class called CLinker in the API, and the name CLinker implies that it's actually bound to the C language. So the Java runtime knows that my function messageBoxW was originally written in C. Why is that necessary? The way you put data into memory is specific to the language used when writing the original code. So in Pascal, for example, an integer is differently encoded than an integer in C. So we have direct support for the C language here, which is a pretty cool thing, because in future you could write more such linkers for different languages. For now, the C linker is enough, because most APIs are originally written in the C language. And the linker is doing a pretty cool thing. It now maps the int from Java to the int of C language, and the memory address of Java to a pointer in the C language, and so on and so on. It can do even more. If you see here, the C linker is also capable of converting Java strings given a target encoding into a C string. So the result of this is that you have a handle to a string that was provided in Java but was converted to UTF-16 LE in the operating system's memory. In the next step, we use the thing that came out from the linker to invoke the actual code. So what is that thing that we got here? This is a method handle, and method handles you already know from Java 8. So under the hood, what the Java runtime does is totally cool. It feels to the Java runtime that you are calling Java code, but when it comes to the actual invocation, it will directly invoke the native code inside of the DLL. And all parameters that were passed in Java are already converted into the heap memory of the operating system. And this is really fast. And the actual invocation you can see here, where the method handle is told to invoke exactly the method with these parameters, which is the C representation of the value null, so a null pointer actually, then the memory address of the first converted string and the memory access of the second converted string, which is the text and the caption. And here we have one more parameter. This is the last int, which simply says I want a simple message box, but nothing fancy with buttons or icons or that. So to sum up the steps, we load a library, we look up the function inside of the library, we define the signature in the original language, here in C language, we define the signature in the target language, which is Java, certainly. Then we ask the C linker to provide the glue code inside of the Java runtime that converts the parameters and that will actually do the function call. Then we convert our strings, and then we do the actual function invocation with the original memory addresses in the operating system heap. And by the way, we even get back data from the operating system, but we don't need it here in our example. We even could imagine that in future somebody wants to support different invocation methods. So for example, if the original function was not written in the C language, but in the Pascal language, and I could imagine that the API is flexible enough that you provide your own linker for Pascal, for example. Okay, enough about the theory. I want to see the thing running, right? So let's go to the command line. I deliberately did not use an IDE. I don't want to see any IDE magic go around. I want to see the real bits. So what we do first is simple compilation using Maven. So I do mvn package and we see it uses JDK16 to compile it. And here it is. And next, drum roll, let's invoke it. This line looks a bit scary. Let me explain it for you. Java, okay, we know what Java exit does. It invokes Java. Then we need to use add modules to explicitly tell the Java runtime that we want to use the incubation features here, which are not part of your module path otherwise. And next, we have to explicitly permit that we use the foreign linker API, because this is a bit security related, as the Java runtime has no control over that memory, so you could do really bad things with it, right? Next, we have to provide our target jar file, which was packaged by Maven. Then we provide the text we want to have inside of the message box. And next, it's here. This is the caption we want to have in the message box. And here we go. Wow, that was quick. Let's do it again. Yeah, JDK16 really rocks. If you want to play around with the foreign linker API and or the foreign memory access API, what do you need for that? Let me start all over. You need requires JDK incubator foreign flag to tell the compiler that you need that module at compile time. You need add modules JDK incubator foreign at runtime to have the module on the module path. You need foreign restricted permit to allow the actual invocation into the native system. And certainly you need JDK16 early access. You can download it from several locations, just pick one and that's it. Actually, there's nothing special in the build process. You see the POM file here from Maven. So you can see here that we want to have the Maven compiler release 16. And to make that work, we are using the Maven compiler plugin in version 3.8.1. And we use the Maven jar plugin in latest version 3.2.0. And we just give it the main class to be able to execute the jar file. But there is nothing special about the foreign linker API here. So to sum up, the foreign linker API together with the foreign memory access API are the holy grail for invoking native code from Java. You don't have to deal with the C language. You don't have to write a shared object or DLL file. You don't have to obtain or distribute something like JNA third party. It works on all platforms. It's part of the Java runtime. And once the incubation phase is over, it will even be part of the normal module space. So it really works out of the box. There's nothing special invoked when it comes to building or when it comes to the IDE, it's really pure Java solution. So while you have to deal with platform specifics, you have to check the parameter sequence and the parameter types. You have to prepare whether it was written in C language. You do that inside of your Java program, and your Java program can check what operating system you're running on and can load different libraries to do the same task on different operating systems. So it's all in your hands of the Java programmer now. You don't have to ask colleagues. You can write it all on your own. Just pick the API descriptions on the web, pick the information, what the data type mapping has to work like, and write pure Java code to invoke it in exactly the same speed or even faster than the JNI API before. So far for this week, and I hope you had as much fun with it as I had. I think this is really great. Java 16 really rocks. Adopt it as soon as you can. And if you like the foreign linker API, or if you like my video, or both, then please give me at least one thumbs up and subscribe to my channel to never miss a new episode. Stay safe and always party on!